Welcome to AS Engineering Academy and AS Online. This is YV Ramaya.
Welcome to AS Engineering Academy and AS Online. This is
Today we are going to start GATE 2026 Score Booster Series. From last 25-30 years we are listening one quotation, nothing but Boost company quotation. Boost is the secret of our energy. I don't know whether it is correct or not, but here this course definitely gives extra energy for achieving our goal either in GATE exam or for securing any right job for our qualification. Here NAT questions, MSQ questions solving. NAT numerical answer type, MSQ multiple select type. Especially for these questions there is no negative marking. That's why while getting solution for these questions, don't leave this. Negative marking is allocated only for MCQ, multiple choice questions. You should keep this point clearly in your mind. Don't leave these questions. At the same time, if it is MSQ, correct answers can be 1 or 2 or 3 or 4. NAT, only numerals are permitted with plus and minus symbols and decimal point. Once again, there is no negative marking for these NAT questions and MSQ questions. Subject is computer organization and architecture, simply computer organization. Session for NAT MSQ questions, simplest solutions. Next look here, just only 1 minute. It is the information what we are having COA questions from 2016 to 2025. Here I have provided the sheet topic wise. First, computer arithmetic. Watch carefully. First of all, computer arithmetic, memory organization, secondary memories, basic processor organization design, pipeline organization, control unit design, IO organization. Here, these are the total number of questions. In 2016, 4 questions. 2016, set 2, 5 questions. Set 1, 4 questions. 2017, 8 questions. If you watch the importance of this subject, if you watch this table, you can able to understand the importance of this subject. It plays essential role for achieving a rank in GATE exam. Next, 2018, out of 65 questions, GATE paper is filled with 65 questions, 7 questions from only our subject. Next, 2029 questions. At the same time, NAT questions are introduced from 2014 onwards. GATE exam onwards. MSQ questions introduced from 2021 GATE exam onwards. Okay, na? From our subject, watch this one. If you watch this table, I have collected NAT questions and MSQ questions. Computer arithmetic. In 2021, 1 question. 2025, 1 question. NAT, total 2 questions. But there were no MSQ questions. Especially memory organization. 2014, 3 questions. 15, 1 question. 16, 2 questions, like that. In total, only from memory organization, we had 21 questions. Which one? NAT and 3 MSQ questions in 2022 to 2024 1. First, it tells this table tells the importance of MSQ and NAT question solution. Next, secondary memories. Total 4 questions. 2015, 2 questions. 2024, 2 questions. Basic processor organization design. 2014, 2 questions. Like that, if you watch all these, 2000, in total, we had 14 questions, but there is no MSQ. pipeline organization. In total, we had 14 questions. In 2024, 2 questions are from MSQ. Next, control unit design. No, we cannot find NAT and MSQ question from this. Next, IO organization. 2016, 1 question. 2021, 1 question. 2023, 1 question. Total 3 questions. It is the most valuable information. Next, look here. I am going to solve some questions at shortest time. At the same time, it is not possible to solve high level questions. Here, from this dais, I am going to discuss easiest questions and moderate questions. Because if I selected complicated questions, only we can able to solve maximum 2 to maximum 3 questions like that in this session. That's why be dedicated in this. First, watch the question carefully. Read question carefully. First, watch the question carefully. Look here. 0x41D 5 zeros is stored in IEEE single precision floating point representation. Decimal value is dash. IEEE single precision floating point representation size is 32 bit. 0x represents hexadecimal. If 0x is placed before data, the data belongs to hexadecimal. 41D00000 with base 16. Look here. It is in hexadecimal. While converting hexadecimal to binary, each hexadecimal digit requires 4 bit 0100 0001. D means 13, 1101. Remaining all are zeros until completing 32 bit. In this, first bit tells the sign. Next 8 bits are used to represent biased exponent. Capital E, biased exponent. First, you find the decimal value for the same. 1, 2, 4, 8, 16, 32, 64, 128 means 131. Means already we know biasing value in single precision notation is 127. That's why true exponent is 4. Next, it is nothing but M value. The expression value for single precision notation means 32 bit is nothing but -1 whole power s into 1.m. M means mantissa into 2 power capital E minus small e, where capital E is the biased exponent, small e is the true exponent. So in this, already we know s is 0 means which type of data it is positive. Next, 1.10100 into 2 power 4. If exponent value became 0, not needed to consider that one in computation. Because of that reason, it is nothing but 11010.0 into 2 power 0 means, look here, you have to shift the decimal point here. 1, 2, 4, 8, 16, nothing but 26. Answer is 26. Good evening to all. Next, come to second question. The size of exponent field in a IEEE double precision representation, floating point representation. Here, double precision means total size is 64 bit. Total size is 64 bit. In these 64 bits, MSB is allocated for sign. next biased exponent, next mantissa. In this, he asked the size of exponent field. 1 bit is allocated for sign, 11 bits are allocated for biased exponent in double precision, 64 bit. Remaining 52 bits are allocated for mantissa. So for this question, answer is 11. Next. The biasing value of IEEE single precision floating point notation is 127. Already we discussed the same thing in first question solution. It is your responsibility to remember this. Next question come here. All these are belonging to computer arithmetic. In IEEE 754 single precision floating point standard, the correct statement C/R MSQ. It is your responsibility to read each and every option. MSQ solution tells a student knowledge level. A student who is having proper knowledge among all the points related to the concept, he can able to solve this. First one, all 32 bits zeros represent special value plus or minus 0. It is false. He asked the correct statement. Why it is false? If S is equal to 0, all zeros means S is 0. It represents only plus 0. All 32 bits zeros represent plus 0 S. It is used to represent plus or minus 0, plus or minus infinitive, and not a number. S used to represent plus or minus 0, plus or minus infinitive, but not a number. No. So correct options B, C. Okay. Next. Last question from computer arithmetic. Read question properly. First understand the question. Consider the following representation of a number in IEEE 754 single precision floating point format with biasing value of 127. He provided biasing value also. Already we know S is equal to 1 means data is negative. Data is negative. Next, capital E value, F values he provided. F is nothing but mantissa. Here, he asked the decimal value of corresponding to the above representation, rounded off to 2 decimal places. Nothing. I am going to provide simplest explanation for this. Here, value is nothing but value, expression value, minus 1 whole power S into 1.m into 2 power biased exponent value minus 127. Here, capital E value is nothing but in binary 1 0 0 0 0 0 0 1. So in decimal 1 2 4 8 16 32 64 128 means 129. It is nothing but 129. Next, at the same time, it is already negative. Minus 1 whole power 1 means negative. 1.m. M means like this. 1.1111 0 zeros. IEEE standards use implicit normalization. That's why hidden bit is needed into 2 power 2. So, to make simple, you have to produce 0 here to get this 111.1100 into 2 power 0. That's why. What about value here? 124, 1 by 2, 1 by 4, nothing but minus 7.75. This value is nothing but 7. Already S is equal to 1. 1 by 2, 1 by 4, 3 by 4 means 75. Yes, some students gave correct answer. Next, look here. memory organization. I am going to provide simplest solution for this. Assume that for a certain processor, it is given in 2015. Assume that for a certain processor, a read request takes 50 nanoseconds on a catch miss. When miss has occurred, it takes 50 nanoseconds, means it's nothing but TMM, main memory access time, 50 nanosecond, miss time, it is nothing but T miss time. Next, 5 nanoseconds on cache hit, TCM, nothing but T hit, 5 nanosecond. At the same time, hit rate provided is 80%, 0.8. What he asked, average read access time in nanoseconds, average memory access time, hit rate 0.8 into hit time 5 nanoseconds plus miss is nothing but 0.2 into miss time is nothing but 50, nothing but 10 plus 4, 14. So our answer is 14 for this. Copy this. Watch this one. Next, watch this one. It is also from cache memory. A cache memory that has a hit rate of 0.8 and access latency 10 nanosecond, nothing but TCM. What is hit rate? 0.8 TCM, cache memory access time 10 nanosecond. Miss penalty 100 nanosecond, means T miss penalty 100 nanosecond. First look here, get clarity in this. CPU, let it is cache memory, let it is main memory. What is miss penalty? Be dedicated in this. Miss penalty means amount of time needed to transfer a word from main memory to cache memory, nothing but miss penalty. When miss penalty is given, you should consider series connection. Okay, at the same time, look here. In this, what he provided in this, however, the optimization results in an increase of cache access latency to 50 nanosecond, means an optimization is done on the cache to reduce the miss rate. To reduce the miss rate means to increase the hit rate. He done the optimization. The optimization results in an increase of cache access latency is 50 nanosecond, whereas the miss penalty is not affected, means there is no change in the main memory access time. The minimum hit rate round off to the 2 decimal places needed after the optimization, such that it should not increase the average memory access time, is dash. First of all, before optimization, what about average access time? Here it is series connection. That's why average memory access time is nothing but AMAT, HCM into TCM plus 1 minus HCM into TMM plus TCM. Why? It is series connection. If you provide all those things here, HCM is nothing but 0.8 into 10. Next, 1 minus HCM is 0.2 into 10 plus 100 means 110. 110 means 110 into 0.2 means 22. 22 into 8 means 30. So, before optimization, AMAT is nothing but 30 nanosecond. After optimization, that value should not be changed, should not be increased. Means you have to take maximum that one only. Means look here. 30 nanoseconds is equal to HCM, new HCM after optimization. Look here. New HCM into what is TCM? 15 nanosecond plus 1 minus HCM new hit rate into 115 nanosecond. Why? TMM has been increased to 115. Here, TCM has been increased to 15 nanosecond. That's why. If you produce these values here, in this, nothing but nanoseconds, all nanoseconds get cancelled. That's why 15 HCM plus 115 minus 115 HCM is nothing but 30. So finally 100 HCM is nothing but minus 100 HCM is equal to minus 85. That's why what about HCM? New HCM. New HCM is nothing but 0.85. So what should be our answer? 0.85. Next. Look here. Excellent question it is. Given in 2020 GATE. Here, if there are M input lines and N output lines for a decoder that is used to uniquely address a byte addressable 1 KB RAM. Type of memory is byte addressable. Size of RAM is 1 KB. What is memory size? 1 KB means 2 power 10 bytes. Here, then maximum value of M plus N. To address a memory chip, we require a decoder. Name of the decoder is memory address decoder. Number of outputs needed for the decoder must be equal to the number of words present in the memory. Here, how many words are present? 2 power 10. So, here, size of decoder is N input. That's why maximum number of outputs 2 power N. Here, 2 power N is nothing but a 2 power 10. Then automatically N is equal to 10. So, here he asked it is nothing but N, it is nothing but M. He asked the M plus N value. Here, M inputs. Here, look here. M inputs means 10 is the inputs. And at the same time, nothing. According to information given here, generally we require the size of N into 2 power N, but here according to information given here, M inputs and N outputs. From this, number of outputs needed for the decoder must be equal to number of words present in the memory, nothing but N value 2 power 10 according to information given in the question, N outputs. Then automatically M value becomes 10 because decoder standard size is N into 2 power N, standard size it is. What N tells? Number of inputs. What 2 power N tells? Maximum number of outputs. That's why according to this value is nothing but 1024. So, M plus N is nothing but 1034. Okay, next come to next question. Excellent question it is. You should solve these type of questions in shortest time. I am going to explain shortest technique to solve this type of questions. Given in 2014, excellent question it is. Look here. A four-way set associative cache memory unit with capacity of 16 KB means CM size is cache memory size is 16 KB. 16 KB means 2 power 14 bytes. 16 KB means 2 power 14 bytes. At the same time, block size is 8 words. BW, number of words in a block, 8 words. But word length is not 8 bits, 32 bit. At the same time, size of the physical address space is 4 GB. Main memory storage capacity. Physical address space means main memory. Size means storage capacity. 4 GB means 2 power 32 bytes. Later what he asked? The number of bits for tag field is dash. Look here. Very important statement it is. While computing tag field size. Here one expression is there. PA minus CA plus log n. While using this expression, you should take proper care whether main memory and cache memory are expressed in the same units or not. If main memory and cache memory are expressed in same units, means here bytes, here also bytes. No need to consider the word size and remaining parameters. Now it is nothing but PA, physical address size. It is nothing but CA. Here already associativity is equal to n is equal to 4. That's why log 4 means 2. It is nothing but 18. 18 plus 2, 20. Suppose main memory storage capacity and cache memory storage capacity are not given in the same units. You should convert both parameters into same unit. Then only you are permitted to use this expression. Sharath, yes, you are following class very well, but small modification is needed. Mesura, yes. Yes. Be positive, yes. Abhida, yes. Take half minute time, try to get solution. I expect the solution from your side. Kiran Baggu, yes. Mesura, yes. Yes. Next, Abhida, yes. Be positive, yes. Nice name it is, be positive. Watch my explanation for this. In this, width of the physical address on a machine is 40 bit. Means PA size is 40 bit. Physical address size is nothing but main memory address size. PA size 40 bit. At the same time, width of the tag field on a 512 KB 8-way set associative cache is dash. Here n is equal to 4. Size of cache memory 512 KB means 2 power 19 bytes. So CA is equal, cache address size is 19 bit. Already we know the expression for finding the tag field size. PA minus CA plus log n. Here if you apply this one, nothing but 21. Here associativity, not 4, here 8. Given associativity is 8. That's why 21 plus 3, 24. Answer is 24. yes, Sharath, yes, Gyan Mark, yes. Next, come to next question. Take half minute time, get solution, read question properly. Read question properly. Cache memory unit with capacity of n words and block size of b words is to be designed. If it is designed as direct mapped cache, length of the tag field is 10 bits. If it is direct mapped cache, length of the tag field is 10 bit. If the cache unit is now upgraded, means redesigned as 16-way set associative without changing other parameters, what is the new tag field size? Very simple it is. Mesura S, Kiran Boggu S, here nothing. First B positive S, Abhida S. For solving these questions, first you should compute the tag field size for direct map. If it is direct map cache, already we know it is nothing but PA minus CA when physical address and cache address are given. It is nothing but 10 bit. And for finding the tag field size for n-way set associative plus log n, what is n here? Associated with 16, log 16 means 4. So answer is 14. Next, come to next question. Here 2017 question. Take only 1 minute time. Consider a machine with byte addressable main memory of 2 power 32 bytes. What is PA here? 32. Divided into block size of 32 bytes means number of words in a block is 2 power 5. Assume that a direct mapped cache having 512 lines means CL number of cache lines 2 power 9, BW 2 power 5 number of cache lines 2 power 9 means CMW number of words in cache memory BW into CL means 2 power 14, 2 power 14. Then what about CA here? 14, PA here 32. Then direct mapped cache value is 32 minus 14 means 18. PA minus CA. So what about our answer 18 bit? Now Mesura S, Kiran Boggu S. Okay. Next, go for solving next question. Only 15 seconds time. Watch question carefully. Abhida, you also correct for this. Watch this. Address bus width of a memory size 2048 into 8 bits. Given memory size is 2048 into 8 bits. He asked the address bus size. Tell me your answer immediately. B positive, yes. Gyan Mark, yes. Mashura, yes. Sharath, yes. Nothing. 2048 means 2 power 11 into 8. 11 is nothing but n number of address lines. 8 is nothing but m number of data lines. He asked the address bus size. That's why 11. Next, come to next question. Take 1 minute time, only 1 minute time. No problem for this. Take 1 minute time. I expect the correct answer for this. If there are P input lines and Q output lines for a decoder that is used to uniquely address a byte addressable XKB RAM, the P plus Q value is 4108. Then X value is dash. Size of P is nothing but P into Q. What is Q here? 2 power P, because standard size of decoder is n into 2 power n. That's why here P plus 2 power P is equal to 4108. From this, tell me your answer for this. Kiran, Baggu, yes. Meshura, no. Read question carefully. Meshura, read question carefully. No need to remove your answer. Think once again. Meshura, yes. Nothing. I give simple explanation for this. Here, 2 power P value is much larger. It is nothing but, if you compute this one, P value is compulsory 12. 12 into 2 power 12. How many outputs are there? 2 power 12 means 4096 outputs. These 4096 outputs are used to address 4096 bytes. It is nothing but 4 kilobyte, because 1 kilo is nothing but 2 power 10 means 1024. Because of that reason, x kb means it is 4 kb. He asked the x value 4. Excellent question it is. Next, come to next question. Given in 2023, you are permitted to take only 1 minute. In this, an 8-way set associated cache size of 64 kb, n is equal to 8, and at the same time, used in a system with 32-bit address means PA size is 32-bit, and what is the cache memory size? 64 kb means CMW 2 power 16 bytes. So CA is equal to 16. He asked the tag field size. Already we know PA minus CA means already we get 16. 16 plus log 8 means 3, 19. Pen and paper are not needed for this. Be positive. Kiran, Abhida gave correct answer for this. Next, come to MSQ question. Excellent question it is, MSQ. Read question properly. Tell me your answers. Given in 2022. Let WB and WT, write back cache, write through cache, be two set associated cache organizations that use LRU algorithm for cache block replacement. WB is a write back cache and WT is a write through cache. Which of the following statements is/are false? He asked the false statements. Okay, take 1 minute type. He asked the false statements. MSQ question, excellent question it is. You should solve the question at shortest time. When you are having clarity in the concept, no extra time is needed for this. Look here. Abhida yes, B positive yes. Look here. Each cash block in WB and WT has a dirty bit. It is false. Why? Dirty bit is needed only for write back but not for write through. Every write hit in WB leads to data transfer from cache to main memory. When write hit has occurred in WB, no need to transfer the present cache line to main memory. That's why it is false. What he mentioned, every write hit in WB leads to data transfer from cache to main memory. No. Eviction of a block from WT means write through will not lead to data transfer from cache to main memory. Yes, true it is, because if it is write through cache, whenever processor wants to evict a current block for mapping new block in its place, then not needed to transfer the present cache content to main memory because it is write through. While performing writing operation, processor writes that one not only in cache memory but also in main memory directly. That's why it is true. Not will not lead to means true. A read miss in WB will never lead to eviction of a dirty block from WB. It is false, because what he told, a read miss in WB in write back cache read miss has occurred means new block is needed to map from main memory. That's why whether the current block present in that one is dirty or clean doesn't matter. Eviction is compulsory needed. Never lead means it is false. So what are false statements here? A, B, D. True statement only C. Next, come to next one. (24) gate question on write through write back only. Take only 2 minutes time. 2 minutes time, because memory organization is most essential topic. That's why take 2 minutes time. Consider two set associative organizations. Look here. Consider two set associative cache memory architectures. WBC, which uses the write back policy, WTC, which uses the write through policy. Both of them use the LRU technique for block replacement. The cache memory is connected to the main memory, means series connection. Which are the following statements E/R false, means it is also MSQ, because he asked E/R. A read miss in WBC never evicts a dirty block. Tell me, is it true or false? It is false. A read miss in WTC never triggers a write back operation. A read miss in WTC, sorry, first option A read miss in WBC never evicts a dirty block. Evicts a dirty block, it is false. Why? In write back cache, miss has occurred. Compulsory new block is mapped from main memory to cache memory. Eviction is needed. What about B? A read miss in WTC never triggers a write back operation of a cache block to main memory. True. Why? In write through, not needed to write that one in main memory. Write miss in WTC always writes the victim cache back to main memory before loading the miss block to the cache. It is false. Why? It is write through. No need to write the present cache information on main memory. A write hit in WBC can modify the values of the dirty bit of a cache block. Yes, it is true. Why? When write hit has occurred, the dirty bit will be modified, means rewrites. So correct answer is B, D. That's all. Next. Next, come to next question. MSQ question regarding associative memory. Watch question carefully. In associative memory, the correct statements E/R. is faster than cache memory. Associative memory, also known as content addressable memory, it is faster than cache memory. Yes. It requires complex hardware circuit for each cell design. Yes, because for matching purpose, complex hardware logic circuit is needed to design, so it is more expensive. It is also known as content addressable memory. Yes, because a word can be addressed with the help of its content, not with its address. No address is needed to address a word from CAM. Is used to design main memory in a system. False, because generally main memory is designed with dynamic RAM. Content addressable memory is used to design tag memory in cache design. So that's why correct options A, B, C only. Okay, next come to next one. Hard disk question, magnetic hard disk. Take 1 minute time. Please try to solve this question. Only 1 minute time. 1 minute time is more than enough for this. Consider a 512 GB hard disk with 32 storage surfaces. What is H? Number of heads means number of surfaces, 2 power 5. What is storage capacity? 2 power 39 byte. 512 GB means there are 4096 sectors per track. S is equal to 2 power 12, 4096. Each sector holds 1024 bytes of data. B is equal to 2 power 10. He asked the number of cylinders in the hard disk. Storage capacity of hard disk is nothing but H into T into S into B, nothing but 2 power 39 byte. What is T here? Number of tracks per one surface. Number of tracks in one surface is nothing but number of cylinders in hard disk. So this value can be replaced with C. That's why C is nothing but 2 power 39 byte by, what is H here? 2 power 5, S here 2 power 12, B here 2 power 10, means 2 power 27 bytes, means nothing but 2 power 12, nothing but 4096. Our answer is 4096. Next. One more question related to secondary memories. It takes some time. That's why I am going to discuss another energetic topic. If time is there, then we will return back to solve the same question. Look here, excellent question it is. Read question properly. From basic processor organization design. A computer system has 32-bit instruction. What is the instruction code size? 13 bits. What is instruction code size? 13 bits. And supports 0 address and 1 address instructions. It supports 0 address and 1 address instructions. The memory contains 128 watts. Means what is address size here? Address size. Log 128 means 7 bit. If there exists 32 1 address instructions, then number of 0 address instructions supported by the system is dash. Take only half minute time. Anybody? Nothing. Look here, I give simple explanation for the same. Here, what is the instruction code size? 13 bit. These are used for 0 address and 1 address. Means if it is 1 address, here 7 bits are needed for address field, 6 bits are needed for operation. If it is 0 address, it is for 1 address. It is for 0 address. No address field is needed, all are used for operation. In this, what he mentioned in this, look here, Maximum number of unaddressed instructions to be formulated is 2 power 6 means 64. Out of 64, how many it uses? 32 means this difference is nothing but free combinations. How many? 32. Each free combination is going to generate additionally 2 power 7 additional opcodes, means into 2 power 7 zero address, because zero address does not require any address field. That's why it is 2 power 5 into 2 power 7, 2 power 12, 4096. Means number of zero address instructions to be supported by this one is 4096. Next, one more question, look here. Read question carefully. Try to solve this question. A processor has 64 registers and uses 16-bit instruction format. Instruction size is 16-bit. It uses 64 general purpose registers. It has two types of instructions, I type and R type. Each I type instruction contains an opcode, a register name, and a 4-bit immediate value. Each R type instruction contains an opcode and two register names. If there are 8 distinct I type opcodes, then maximum number of distinct R type opcodes is dash. Watch question carefully. Take 1 minute time, no problem for this. Take 1 minute time. Try to solve the question. Okay, watch my explanation. Nothing. Here, look here. It is instruction. Be dedicated in this. Apply the given values here. What is total size here? 16-bit. Now it is divided into two types, I type, R type. What is I type characteristic? Each I type instruction contains an opcode. Here operation means opcode means operation. Next, a register name and 4-bit immediate value. What it is? IV immediate value 4-bit. Register field requires 60 to address one of the 64 6 bits. Out of 16-bit, 10 bits are consumed here. That's why operation size is 6-bit. If it is R type, what he mentioned, each R type instruction contains an opcode and two register names. Opcode means operation. Here RX and RY. To select one of the 64 registers, we require 6-bit here, 6-bit here. Operation size is 4-bit. Here maximum number of R type is 16. Then you cannot formulate even single I type. Maximum number of I type is 64. You cannot formulate even R type, single R type. That's why some combinations are used to I type, remaining combinations are used to R type. How many R types are? How many I types are used? 8 means if it is I type, only address size is 10-bit. Means for I type, 8 instructions are there. 8 into 2 power 10. Why 2 power 10? Address size is 10-bit. 2 power 10 combinations are needed for each one. Plus, what about R type? Into, what about R type here? You have to find this one. That's why what is address size? 2 power 12. Why 6 plus 6 is equal to, what about this one? Size is 16 means 2 power 16. So from this, R is nothing but 2 power 16 minus 8 means 2 power 3 into 2 power 10 means 2 power 13 by 2 power 12, nothing but, what about this? 2 power 13, here 8, 2 power 3 minus 1, 8 minus 1 divided by 2 power 12 means it is nothing but 2, 2 sevens 14, So what about our answer here? 40. Here we don't have enough time, that's why I am going to solve one question from pipeline. Energetic question. Two questions. It is the first question, look here. MSQ. Be dedicated in this. An instruction format has the following structure: instruction number, opcode, destination register, source register 1, source register 2. Means these are the instruction numbers. Instruction numbers. Next opcode. Next source destination register, source register 1 and source register 2. He gave 4 instructions. Which of the following statements C/R true? There is WAR, means anti-dependency. On R3, he asked only R3, on R3 only, between I1 and I3. If you consider I1 and I3, RAW means anti-dependency. I3 output is R3. It is not present in input of I1, so false. There is a WAW dependency on R3 between I3 and I4. In I3 and I4, if outputs are same, then WAW occurs. Here, I4 output is R7, that's why false. Option C. There is a RAW dependency on R3 between I1 and I2. RAW means true dependency. I1 and I2. I1 output is present in I2 input, that's why it is true. Next. There is RAW dependency on R3 between I2 and I3. RAW means true dependency. In I2, I3, I2 output is R5, but he asked on R3 only, that's why it is false. Even though it is MSQ, correct option is only C, single one. So if it is MSQ, correct answer can be 1 or 2 or 3 or 4. Last question, it is my favorite question in pipeline. 2024 question. Take 1 minute time, try to solve. Okay, no. Last question, be dedicated. Consider a 5-stage pipeline processor with instruction fetch. What about this? Look here. 5 stages, instruction fetch. Names are instruction fetch, later instruction decode, later execute, later memory access, later write back. Means it is a RISC processor, classic processor. First of all execution, then only memory access. Following statements about forwarding are correct. Which of the following statements about forwarding are correct? What is forwarding? Very simple and very clear. When target input operand is not available, forwarding is the process of transferring execute stage output to the input of same or MA stage output to the input of the same execute stage. Not from WB. Look here. In a pipeline execution, forwarding means the result from a source stage of earlier instruction is passed to the destination stage of later instruction. Yes. Next. Forwarding cannot prevent all pipeline stalls. Yes, because forwarding can prevent only RAW stalls but not branch stalls. Forwarding does not require any extra hardware to retrieve the data from pipeline. To retrieve the data from pipeline, it requires extra hardware, that's why it is false. In forwarding, data from the output of the memory stage can be passed on to the input of the EX stage. Output of memory stage can be passed on to the input of the EX stage. of the next instruction? Yes. So correct options A, B, D. Okay. Thank you very much and best of luck.